Guys, welcome to this video. Today we will master stack together. We will see what is a stack, how you can create a stack in Python, and how you can use a stack. Okay, but what is a stack? As you can see on the screen, I have a picture, okay? And then in this picture, we will explain in great details what is a stack. So after watching this video, you should be able to explain it to you should be able to explain what is a stack to any kid with 7 years old, and they should be able to understand. So let's get started, right? A stack is a linear data structure that follows the LIFO principle. The LIFO principle means last in, first out, okay? That is the principle. So also one thing you need to keep in mind, a stack is a data structure that can hold many elements, okay? And the last element added is the first one to be removed. Okay, let's see in great details right here what we want to explain, and then you can have a better idea. The goal, the purpose of this video is to make sure at the end of this video, okay, you should be able to explain what is a stack to anyone, and then they should be able to understand. Look at this example, right? I take all of them. Okay, now you see this one. I'm sorry, it will be like really amazing. So we will follow everything together. You see, these are plates, right? What does that? How does that work? We can only add or we move element from the top. Okay, this is what is a stack. A stack is a data structure that can hold many elements, and the last element added is the first one to be removed. Let me take an example right here with you. Let's say I have a box, right? And in that box, I'm adding some balloons, okay? I add a first one, okay? I add a second one, I add, you see, a third one, and I add a fourth one, okay? So this one right here, okay? This one right here is the last one, correct? This one is the last one that has been added to the stack, and this one is the first one that has been added to the stack. But now how we can like remove this one without removing this one? So in a stack, okay, in order to remove to get this element, okay, you should remove this one, and to get this one, okay, you should remove this one. To remove this one, you should remove this one, and to remove this one, you should remove this one. So this is why it calls like a LIFO principle, because the last element that has been added to the stack is the first one to be removed, okay? This is what you need to keep in mind. Let's take this example. You see, for example, this is the bottom. Well, this plate is the first one, right? This plate is the first one that has been added. Okay, but to remove it, you need to remove this one, to remove this one, to remove this one, this one, this one, and this one. You see, we can only add or remove elements from the top. So now let's see how we can add the element, okay? For example, let's say we already have this one, okay? Let's say we have this stack that is started, right? Okay, we can push, okay? To add an element, we just put we say, okay, we push it, okay? We can push that element to the top of or to the stack. But when we add a new element, it will be at the top. Okay, so right here you see that will be this one, you see. Now we have it like this, you see, it becomes like this. We have like 10, 20, 30, and then you see add 30 to the top. Okay, we push 40, the 40 will be added to the top as well. Okay, but to remove an element from the stack, we should remove the last element that has been added in order to remove anything at the bottom of the stack. We should remove from the top. Okay, so right here, you see, right here, we can also remove. If we remove to pop an element or to remove it, you see. So we if we say pop like or remove 40, it will remove the top, the top, the 40, it will remove the top from the top. Okay, so this is, let's say this, let's take this example as well. This is an amazing example so you can understand everything. You see, okay, we say push 10. Okay, you see, now 10, we have 10. Now we push 20, we have 20. You see, we push 30, we have 30 at the top. We push 40, we have 40. But one thing I want you to keep in mind, okay, let's move on. Okay, so now when we say, okay, we pop, okay, we pop from the stack. Remember what was here, okay? Right here we had like 40, okay? When we pop, now we do no longer have 40, we have this one that is remaining, right? And then when we pop again, the 30 has been removed and we have this one, okay? So this is what I want you to keep in mind. In a stack, you add from the top and you remove. You can only add or remove element from the top. This is everything. This summarizes everything I have been explaining right here. Okay, but there is another thing. What if I want to only get the element at the top, but I don't want to remove that element? Okay, because when you pop it, it removes it and return it to you. And then, for example, let's come right here to see, okay, to pick an element from the top. Pick an element, return the top, okay, or the last element on the stack. Okay, this is, you need to keep this in your mind. And then you see, so now if we pick it returns the top element from the stack. Okay, view the top element. This is what it does. It returns the top element from the stack. And then this one is extremely important. You need to keep this in your mind. Stack follows LIFO principle. LIFO means last in, first out. The last element that has been added is the first element to be removed. That is how a stack works, okay? In, Insertion, okay? When you push an element in to the stack, it should be on the top. And when you pop element from the stack, it will be the last element that has been added, okay? So I believe you understand all these examples. Now let's go to the code, okay? So now let's go to the code. As I have explained to you, uh, basically we can implement a stack by using an array or a linked list. But for the purpose of this video, we will just implement a stack using an array, okay? For example, a Python list might look like that, my list, okay? Might look like that. We can say like 5, 6, 2, 9. That is an example. I'm taking some numbers randomly. Okay, 8, 4. This is a Python like list. And this also can look like a stack, okay? So I have created some quick notes for you right here. So let me, these are the notes. The note says stacks with Python. A stack is a linear data structure that follows the last in, first out principle. This is what we have been talking about. A stack is a data structure that can hold, okay, I'm sorry, many elements. And the last element added is the first one to be removed. Basic operations we can do on a stack are these one. Let's copy this one. Okay, let's copy this one. We will see. Uh, we will put this one right here. So we will do them together. Okay, so let's get back to the code. Stack can be implemented by using a list or by using a linked list or something else. But I have created this list already, and then that's it. Okay, now let's get back to the code. Okay, so we can first let's create a stack. Okay, using a stack list, we can use a Python list as a stack. Let's say let's create a variable called stack, right? And let's assign it to an empty list. Okay, now we will use the push. Okay, we will push element to the stack. Let's say we want to push some element to the stack. What we do stack that happened. Okay, and then let's say we want to push like 23. That's the first element. And then we want to push another element. Let's say we say stack that happened. We say like 78. Okay? We say 78. And then we might say stack that happened again. And then we might say like 45. Okay. So now let's print the stack to see. Print. Okay. We print the stack to see. We can say like my stack. Okay. We can say stack I'm sorry, stack, and then we will pass the stack. We'll pass the stack. We will see the result. Okay, come right here to see the result. I'm sorry, guys, for this one. Okay, this is the result. You see, this is the result. Now, you see, what is the last element that has been added to the stack? The last element is this one. You see where it is? It becomes right here. You see, it becomes right here. So now what we can do, you see, now we have a stack. We have a working stack, and we can continue working on the stack. And then now we can like use other operation. For example, let's say if we want to get the top element from the stack, right? We can say top element, we'll give it a descriptive name so you can have a better idea. Top element, we can say stack, okay? That, okay, we can, to get it, we can say that -1. The -1 will return the last element from the stack, okay? Now we can print, we can say like last element, okay? Last element, and then we will pop the top, we will pass the last element. Let's see what will be the result. You see, we have a stack, okay? And the last element is 45. This is an amazing step, okay? So you understand how to add an element to a stack, how to create a stack using a list, you create a variable called like a stack, or you can give it whatever name you want. And then we to push an element to a stack, we just do stack that happen. That is when you're creating a stack using like a list, okay? So in the future, in the next video, we will see how we can create a stack using like a stack class. After that, when we cover linked list, you will see how you can create a stack using a linked list, okay? But for now, for the purpose of this video, we'll just cover how you can create a stack using just a list or an array. Okay, now we have popped, we have, I'm sorry, we have picked the this one should be right here, guys. I'm sorry. Give me 1 minute. This one should be right here, not pop. Okay, the pop works differently. You will see. This one should be right here, guys. Okay. Okay, now you will see how you can pop an element from a stack. Let's move this one below this one. Let's copy here, and then let's come right here. Okay, now you will see how you can like pop an element from the stack. To pop an element from the stack, when you pop an element from the stack, what it does, it will pop that element and returns that element. And we need to store that element in a variable if we want to use that element. What we can do, we can say pop element, okay? Pop element equal stack dot pop. Remember what we have been talking about. When you pop an element, it will pop the last element, okay? We can say print popped element, and then we pass the element that have been popped, okay? And then now let's see what will be the result. Okay, the element that has been popped is the 45, because in the stack, when you say pop, it will pop the last element and then it will return it, okay? Okay, and then now we can after pop, what we can do, we can check if the stack is empty. That is quite easy. That is quite easy. Okay, to check if the stack is empty, we'll use like a boolean. Okay, we can say, we can store that in a variable. We can say is empty. Okay, and we say like not bool. Okay, and then we pass the stack. I'm sorry. Okay, and now let's print the result to see what will be is empty. Let's print it just like that, is empty, and then to see what it will give us. Remember, we have element on the stack, right? Let's see what it will give us. It should return false because the stack has element on it, right? This is the stack. We check if the stack is empty, but the stack is not empty, so it should return false, right? But let's say if I create another stack, I call it Dave, yeah, and I give it a name, and I pass Dave right here. You see, Dave is empty. There is nothing in Dave. Okay, this is a stack. Okay, oh, let's give it another name. Let's call it stack one. That will be better. Stack one. Let's pass the name of stack one. Stack one. Okay, let's pass the name, and then let's see. Okay, give me 1 minute. Okay. Okay, you see now? You see I pass stack one. Stack one has no element. It returns true because the stack is empty. Okay, that is amazing. That is working pretty fine. Okay, so now let's get back to the current to the normal stack. Okay, okay, it is false because the stack is not empty. You need to keep this in your mind. Okay, now to check the size of the stack. I'm sorry, let me check right here. The size of the stack is the number of elements in that stack, okay? For example, we can say print, okay? Size of the stack, and then we can say length stack. That will return the number of elements on the stack, okay? That is the length of the stack. The size or the length. Okay, the size of the stack is 2. You know the reason why it returns 2? Because it starts counting from like, okay, we have already removed the last element. I'm sorry. That is the reason why it returns 2, because we pop the last element from the stack. So the 45, after popping, the 45 is no longer on the stack. So now we have 33 and 78. So this was an amazing video. Now we have covered how you can create a stack using like a list, and we have seen what is a stack, how it works, and then all of these, okay, we have seen all of these. So now I believe you will be able to create your own stack using a list, and then you'll be able to explain what is a stack to anyone, and then you will have a better idea when you see a stack, what to do, how to add an element, how to push an element to the stack, how to remove or to pop, how to push, how to pick, and how to get the size of a stack, how to like get, how to know how to check if a stack is empty. So that's pretty much it. So thank you for watching this video. If you're watching me on, if you're watching this video on YouTube, do not forget to subscribe to the YouTube channel. If you are watching this video on Facebook, do not forget to follow us. Okay, thank you. Ciao. See you for the next video. We will see how you can create a stack using a stack class. Thank you.